dua, symmetrical and unsymmetrical. Okay, for the unsymmetrical components, in order to analyze the elements of the unsymmetrical, we have to make it as a symmetrical. Kita kena ada some kind of relationship between unsymmetrical and symmetrical components. Okay, so in the symmetrical components, we have positive sequence, negative sequence, and zero sequence. So kita lagi in order to make this become balanced, so we need to have these three sequences: positive, negative, and zero sequences. Okay, someone nak join my room sekejap. Alright. Okay. So for the positive sequence, tahu pun nama pun positive. So means the sequence is positive. Okay. Means if you look here, this is the positive sequence. A, B, C. So dia follow the clockwise. Ikut arah jam. Negative sequence dia counter. Clockwise. Tapi dia punya phasor ni dia terbalik. Phasor dia kalau sequence ke sini, kalau phasor dia ke dia counter, dia different. Tapi from this three diagram, you can see that all the phasors, contohnya for the positive sequence A, B, C, dia some kind of, it has the same magnitude. Kalau kita katakan the length of this arrow ni, dia same magnitude for all the arrows. B, C, and it has same phasor angle sama, which is 120 degree. Okay, so what happened to the unbalance? Kalau unbalance maksudnya means some of the phasor, let's say phase A ni dia maybe in term of magnitude dia lagi much longer lah, lagi panjang contoh ke sini. So maksudnya when the magnitude are not equal to the others, so dia become unbalanced. But for these three cases, all are balanced. That's why kita panggil symmetrical component. Okay, negative, positive, and zero sequence. How about zero sequence? Zero sequence ni beza the difference between with positive and negative. It doesn't have angle atau phasor. Dia just straight line macam ni lah. However, the magnitude are same, sama. Magnitude sama for the three phases. Okay. So how we recognize the positive sequence? Basically, biasanya dalam nota ni lah, we use the small one. Atau kita katakan contohnya VA1. So A1 to representing the positive sequence, 2 representing negative sequence, and 0 representing zero sequence. Okay, faham simple kan? Tak perlu pening. So that's the symmetrical component. This is a voltage. Sama juga same with current. The different only the V and the I. Okay, so this is the current. Ditambah kat sini, kalau ada satu kat atas ni, okay, means that the positive. Number 2 is negative, 0 is zero sequence. Okay, so what is the relationship between unsymmetrical and symmetrical? So kalau ini kita panggil unsymmetrical, yang tak balance. These are the balance. So the relationship is given as this equation. You nampak kat sini lah. For example, for the A symmetrical component for the unsymmetrical of A, VA1 plus VA2 plus VA0. So means that when we add all this means kita kata the relationship between symmetrical and unsymmetrical. So we do this same for our other phases B and C. And similarly for the currents IA, IB, and IC. Konsepnya sama. The unsymmetrical three phases, voltage VA, VB, VC, and currents IA, IB, IC can be determined by adding together their symmetrical components. Right. Okay, so this is the general equation. When we add the phasor, A ni biasa kita represent phase angle. A is equivalent to 1 with the angle of 130 degree. A square is 1 with the angle of 240. So when we do the derivation, we dapat macam ni lah. Relationship of the positive sequence component, relationship between the negative sequence component, and relationship between zero sequence component. Right. Okay. Kenapa dia VA, VB1, A square? Sebenarnya kalau you refer pada phasor diagram, dia nampak lah. Okay. So B kat sini kan. So maksudnya kalau 120 is A, So it needs 2 times A square, 1, 2. Kalau A ni 1 case ni contoh BA, so it has a square double A. That's why question kat sini it has a square relationship between the positive sequence of B1 equivalent to A square VA1. Faham Okay, question ni lah. Alright, this one referring to this diagram. Okay, sama juga yang lain. You boleh tengok, you can see. Right. Then from this general equation for the unsymmetrical component with this symmetrical, okay. So let's say we put in this way, okay. So we can make it put in the matrix form, ni ada, Nama matrix senang je nak kira, senang je nak kira later on, Okay. So these are the relationship. So this is the matrix of A, okay. So this is from this equation, and we can simplify into this equation. Okay. Then we have another relationship. Let's say we are using inverse A matrix. Kita boleh juga put in this way. Tadi in front ni kita letak unsymmetrical. Now we put symmetrical. The relationship between unsymmetrical is 1/3 times the total of VA, VB, and VC for the 0. Sama juga, same cases for other sequences A, positive and negative. So lagi I recall lagi, ada experiment kat you all kan, tapi tak apa, seminggu, sekejap, dah lupa normal lah tu. Right. So benda ni tak tengok hari-hari so masa kelas you tengok, masa nak test you baca, itu normal Okay. Sebenarnya for current in spaces sama juga for the currents. We use the same method to analyze the current. The relationship between this one is unsymmetrical with the symmetrical. Okay. This is we are using the A or this person. Then later on we can put in this relationship between the symmetrical to the unsymmetrical. Sama betul tak? Sama je lah. Cuma different. This is the current. The previous one is the voltage. Okay. Alright. Okay, so this one, this is the IN is the neutral current. Okay, tak apa, later on this one. However, the IN is 3 times IO. If a component has no neutral current, there can be no zero sequence current in the component. No neutral current, zero sequence current is referring to the neutral current. Thus, delta connected, ungrounded, Y connected components cannot have zero sequence components of current because they have no neutral connection. In the connection of transformers, you pun tahu kan there is star, delta, whatever you can. Dia ada connection macam star, delta. These are the connection of transformers. Let's say if the connection of transformer doesn't have the ground, ground ni maksudnya ground is connected to the ground, ada wire sama pada ground, pada bumi, pada to the earth, So kalau tak ada, we can consider that there is no neutral current ataupun IN. Alright, the next one is the, I rasa I stop kat sini. I think kat sini. Today we are going to start from this. No, this one saya tak ingat lah yang ini kita stop. This one belum dah ke ini? Okay, tak apa. Unsymmetrical voltage and current with the symmetrical component. So this is unsymmetrical voltage and current, symmetrical component. Okay. Boleh faham Jadi apa yang you kena faham? Basically you kena tahulah the symbol Kalau kita put contoh VA, VB, VC ni, ini apa? Apa dia ni apa kata tadi? Symmetrical or unsymmetrical? Apa nak jawab? Apa jawab? This is the apa? Which one? Kalau ini?
Iaitu unsymmetrical.
Unsymmetrical, very good. Okay, this is symmetrical. So, ingat basic symmetrical, it has a zero sequence, positive sequence, and negative sequence. Okay. Alright, so faham tu? Okay, good. Sequence impedance and sequence network. Okay. In general, the impedance of a circuit differs for positive, negative, and zero sequence currents. Where only positive current is flowing, the impedance is known as the positive sequence impedance of the circuit. Similarly, for negative and zero sequences. To analyze the unsymmetrical fault, 3 different per phase equivalent circuit must be considered. Okay, now we are going to discuss about the equivalent circuit of positive, negative, and zero sequence. Kenapa? Because we want to analyze the unsymmetrical fault. Jadi kita kena pecahkan. We have to divide it into 3. Positive, negative, and zero sequence. Okay. Sequence impedance and sequence network. Each circuit represents each type of symmetrical component. Positive sequence network, a per-phase equivalent circuit containing only the positive sequence impedance and sources. Negative sequence network. Ni network ni maksudnya the equivalent circuit. A per-phase equivalent circuit containing only negative sequence impedance. Senang kalau positif, dia punya impedance and sources only the positive. Okay. Tapi you kena faham kalau for the positive sequence impedance ni basically it has an impedance and source. There are the two elements here. For the negative and zero, it only has the impedance. Dia tak ada sources. Kenapa? Itu ada. This is how we analyze the sequences. We differentiate the differentiate between the positive, negative, and zero sequence. So the positive, basically it has the impedance and the source. Dan sebenarnya ni kita boleh buat derivation dan you can see lah the different outcome for this sequences. Okay. Look sequence network for generator. The equivalent circuit of three-phase Y connected sequence generator with grounded neutral isolation. So this is the equivalent circuit. Semua tahu, semua faham kan? So this is the generator. Where three-phase generator, it has a unique EMF voltage, EA, EB, EC. So this is the impedance. Impedance. And this is the current, IA, IB, and IC. Okay. Let's look, because kita nak analyze, so we want to analyze the fault, unbalanced fault or unsymmetrical fault. So we need to know the positive and negative sequence. Okay, ingat case tadi I cakap positive, it contain the impedance and sources. However, for the negative and zero sequence, it only has impedance in the network. Okay, look at the positive sequence network. So this is the positive sequence network. You can see here. Right, if we draw the equivalent circuit, ini ada bentuk dia, right. Okay, so for the positive sequence, it has the EA, EA this one, EMF voltage, sources, and the internal impedance of positive sequence, that one. So we can determine the value of terminal voltage kat sini, VA1 ataupun VA positive sequence. Okay. Equivalent to the EMF voltage minus the voltage drop across the impedance. So you dapatlah the value for the terminal voltage for positive sequence. So this is the positive sequence network for generator, which has PA. So how the sequence network for negative? So again, negative, it doesn't have the PA. Nampak pun kosong kat sini, tak ada. So you kena faham. If you need to draw, sketch the sequence of the negative, so make sure you don't draw the sources. Dia tak ada source. It only has the negative sequence impedance. Z2 is negative sequence impedance. So the numbering pun kena betul, labeling pun kena betul, jangan salah. You draw the negative sequence but you put Z1, so salah lah. So you must put in the right way. If the negative sequence, make sure you use number 2. Okay, so this is the equivalent circuit. So how do we determine the terminal voltage VA2? So this one, minus IA, A2, Z2. Kenapa dia minus? Sebenarnya dia sebab dia consider kosong. There is no sources. So jadi 0 minus something here kat sini. Voltage drop kat sini become minus. Alright, for the negative sequence, sama. However, negative ni basically we need to consider the neutral impedance. That's why kat sini dia ada neutral impedance. And this is the generator, ZG. Z0 pun boleh juga, sebab this is representing 0. However, you need to add the 3 times Zn, because 3 phase, you kena dekat darab 3, 3 times Zn. Impedance for the ground. Okay, because 3 phase, there are 3 zero sequences of currents, IA, IB, and IC flow through this Zn. That's why they are the 3 times Zn. Okay, so this is the equation to determine the VAO as the terminal voltage, equivalent to minus IAO, I0, Z0. Okay, alright. Oh, this is the sequence network for generator, positive, negative, and zero sequence. Okay, so look at the sequence. Okay, this is the better summarize lah among the sequences, positive, negative, and zero sequence. So this is the voltage for positive sequence, negative sequence, and zero sequence. Ini kena ingat lah. Okay, you have to memorize this circuit and this circuit. Okay, for generator. This is only for generator, valid for generator. Okay, alright. Kenapa generator? Because in power system network, we have a generator. Okay? That's why kita kena tahu circuit for generator, positive, negative, and zero sequence. Okay. The next one is a sequence network for transformer. Okay, generator. The next one, of course, transformer. Okay, you belajar power system element. Generator, of course, second equals to transformer. Lepas tu line. Itu yang you akan lihat later on in the next slide. Okay, sequence network for transformer. The equivalent circuit of transformer for positive, negative sequences network is identical. Alright, sama. It consists of just series impedance of the transformer regardless of primary and or secondary connection, Y or delta. Jadi sebenarnya dia for sequence for transformers, the positivity sama. It only has series impedance. Okay, transformer tak ada source, that's why dia only impedance. For zero sequence impedance, however, there are 5 possible cases depending on their connection at primary and secondary side. Table below show the connection diagram for zero phase sequence for various type of transformer. Okay. Kat sini dia beritahu positive ni sama dalam nota ni dia tak tunjuk lah. Dia cuma tunjuk untuk zero sequence. Because zero sequence ni there are about 5 possible cases. Ada 5 possible cases. Kenapa Okay, look here. Okay. Transformers, you tahu transformers. This is phase transformers. So there are 2 type of connection for transformers. There are the Y connection and delta connection. Betul So kita sambung transformer in the transmission tu, it can be 5 possible connection. In this case, the YY connection. Maksudnya dekat primary and secondary connected in Y. Okay? Ada ground pula tu. Ada ground kat sini. Mungkin yang ini pula YY, but both primary, secondary has ground. Dia ada ground. Okay? Both have ground. Okay, dia yang lain, inilah Y delta connection. Ini Y, ini delta. And the Y has ground. Jadi, what the effect of grounded? Dia ada delta connection. Okay, this is Y delta without the ground connection. Okay. Okay, ini ialah delta tapi juga tidak ada ground. Okay, look here. Because this is zero sequence. Bila kata zero sequence, we focus on the neutral current, IN. Okay. The first one, YY connection. It has a ground connection. So, in order to draw, to sketch the zero sequence equivalent circuit, dia kena draw macam ni. Kenapa dia jadi macam ni? Okay, I kena zoom the size of diagram. Okay, nampak kat sini clear kan? Okay. YY connection with ground connected in the middle. Y connection biasanya memang ada ground. Memang ada ground untuk purpose of protection, fault current, whatever, dia akan masuk ke ground. Okay. Alright. Okay, for the zero sequence equivalent circuit, you can sketch macam ni. ZO is the zero sequence impedance, because this is zero sequence. Jangan tak Z1, ZO lah, because zero sequence. Okay, and then it open circuit. Kenapa open circuit? Because the neutral current from the primary cannot cannot go to the secondary current, secondary side, sebab dia tak ada ground. Masa kalau masuk ke ground pun dia takkan ke sini, dia tak ada connection. This one tak ada connection, that's why dia open circuit. Reference is a ground sebenarnya ni. Inilah ground, reference. How about this one? This one is a star with ground connection. Means that the current ni dia boleh IN, misalkan it can go to the ground and then it can go to the secondary side through this ground. Boleh nampak kat sini kan? So current flow from all the phases that is joined at this line, go to the ground and come back from this ground to the secondary. That's why connection for a zero sequence equivalent circuit, you have macam short circuit lah, straight line lah kita kata. This is the reference. Okay. Faham kenapa ni open? Ini close. Because current from the primary can go to the secondary. Okay, the next one is what? Okay, for the delta connection, Y delta. So this one, even though at the delta dia tak ada, it doesn't have the, kita panggil apa? Ground, tapi current can circulate, dia boleh circulate. IN will circulate in the winding of primary. Ini dia winding lah. So that's why dia ke sini. Tapi dia tak boleh nak cross, cannot cross the secondary because dia tak ada ground. So dia jadi macam ni lah. So the current IN go to the ground. However, it cannot go to the Q point. Kat sini tak ada, because dia tak ada ground. Okay, faham Okay, Y delta, let's say tak ada, both ini tak ada. Of course lah, dia jadi open circuit. Dia open circuit. Right, dia jadi open circuit because current from phase A, phase B, phase C, and the neutral current zero sequence cannot go to the ground. That way to the ground, then of course dia cannot cross to the secondary side. Dalam case ni is delta. So full circuit you can draw like this. Jangan salah lah. Okay. And the last one is delta delta. Okay, delta delta. Okay, how even though it doesn't have the ground, okay, but the current again it can circulate. Dia boleh circulate lah, dia boleh berpusing circulate around the delta connection. That's why when you catch the circuit dia macam ni. Kenapa dia tak boleh? Because kenapa dia ke ground? Itu connection lah untuk delta. You want to show that the current is circulate. Dia dekat area sini. Right? Okay. So these are the 5 possible connection of transformer for different connection, delta, Y delta, YY with ground, and then these are the sequence equivalent circuit. So banyaklah you kena ingat circuit. For example untuk generators, positive, negative, zero. Tapi tak usah pun sebenarnya. Kalau for the generators, remember for phase A, only phase A has the source, EMF electric voltage. For the negative zero, it doesn't have the source. Okay. For zero sequence, you have to add the neutral impedance times 3. Okay. And then for the equivalent circuit for positive, negative, sama, right? However, for the negative zero sequence, it has a 5 possible zero sequence equivalent circuit. So this one you have to tahulah, or you have to remember. Okay. Type of unsymmetrical fault. Okay. First we discuss about the generator. Then we go to the transformers. And then the next one is the line. Okay. Because setiap element in the power system tu dia akan ada fault. Dan dia akan fault can be occur at any element. It can be a generator, it can be a transformer, or it can be at the line. Okay. So this is next to the line. As mentioned before, 3 types of unsymmetrical faults are single line to ground fault. So this is single line to ground. Okay. Line to line fault. The other line A and line B, they are shorted. And the other one is double line to ground fault. Double line shorted together and it connected with the ground. So these are the type of unsymmetrical fault. Ada lagi tak? Type lain? Ada tak? 3 ni lah rasanya. Ada lagi? Kalau straight shorted 3, apa jadi? Apa kan jadi?
Jadi symmetry.
Ya, jadi balance fault or symmetrical fault. So ini clear lah. Right? Kenapa dia jadi unbalance? Because impedance dia dah tak sama. Bila dia ada short circuit, impedance dia jadi kosong kat sini. Jadi impedance between the lines are different. Bila impedance tak sama, current flow tak sama, voltage tak sama, dia menjadi unbalance. Tapi kalau shorted together, tiga-tiga bersama, tiga-tiga shorted, itu impedance sama, that's why dia jadi symmetrical fault. Ini pun samalah unsymmetrical. Okay. Okay, look at the first one, single line to ground fault. Okay, single line, let's say this is a generator with single line fault on phase A is shown below. So there's a line kat sini, right? Line A, line B, line C. Because this is single line to ground fault, we consider, let's say phase A is short circuit with the ground. Kita panggil single line to ground fault. Okay? So what happen is IB, IC become 0. Bila ada short circuit, biasanya voltage A kosong, dia tak kena voltage short circuit, kosong voltage. And IB, IC juga become 0. Yeah? Right. So we can do the derivation. Sebenarnya kita nak cari what is the value of positive sequence currents during the fault. So this is the general equation. Okay. For example, IA1 equivalent to EA1 divided by the total impedance Z0, Z1, and Z2. So this is our target and objective to have this relationship. Later on, kenapa kita nak draw the equivalent circuit? Tadi lah, we want to know equivalent circuit by referring to this equation. So ini semua ialah the derivation. Okay, we look at one by one. Okay, in the case of single line to ground, IB, IC is 0. Both are 0. The critical components of current in phase A are given as this equation. Ini equation sebelum ni. Right, so we can make the simplification, and then we have this equation 1IA0 equivalent to 1/3IA. Okay, then recall for the voltage. For the phase A, fault at the phase A, the fault phase A, you can consider the voltage, EMF of positive sequence. So negative sequence, zero sequence, doesn't have a voltage. Dan ini equation tadi lah, the first dalam slide yang awal tadi, the earlier slide that I show you. Okay. Then when you do the substitution for this equation, you have this one. Okay, later on when make all the derivation process, you akan dapat equation yang ni. Okay, so dia. So just substitute into the circuit equations from the circuit. So you have this general equation for positive sequence current. Okay. IA1 equivalent to EA1, Z0 plus Z1 plus Z2. So from this general equation, we have this positive equivalent circuit, positive sequence. Okay. 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 For example, IA1 equivalent to the EA divided by the total impedance. Kalau you tengok sini pun, you can draw the circuit EA. Okay. You have to put in this series connection for zero sequence, positive sequence, and negative sequence. And then you have to add the fault three phase. This is ZF is the Z fault. Mana datang ZF ni? Because it comes from this fault. Kat sini biasanya akan ada Z fault. Dekat slide tak tunjuk tapi sebenarnya kita ada impedance of fault ZF kat sini. That's why in the equation you have ZF. Okay. Alright. Okay, so this is a relationship in the single line ground fault. Single line ground is modeled as IA0. Maksudnya means that from this equation we can say that zero sequence, positive sequence, and negative sequence in terms of magnitude are same, sama. And then we can do this. We have this equation. Then we can have this fault current. Relationship between unsymmetrical with the symmetrical positive. Okay. Right. Second one is the line-to-line fault. Bila kata line-to-line fault, this is the line-to-line. Contohnya, still lagi fokus generator. We have phase A, phase B, phase C. Because line-to-line means that, let's say phase B and C, they're shorted. Ini ada fault. Okay. So whatever is VB, VC equivalent to each other. VB equivalent to VC. Okay. IA is 0 and IB equivalent to minus IC. So we use the relationship of the positive, zero sequence, positive sequence, and negative sequence. This is A from this general equation. Yes, later on, for the equation. So you have the derivation that you can see that VA1 equivalent to VA2. Okay, ini sama. Kalau kita pasal derivation sebab you takkan buat derivation kita ni. Alright. Process, you do all the derivation here, then you can get the general equation for the line-to-line fault. IA1 equivalent to EA1 divided by Z1 plus Z2. Okay. Okay. So now the sketch the line-to-line fault from this equation. Dia nampak lah. EA1 maksudnya kat sini dia ada EA1. Okay. Sorry, this is betul lah. Okay. Z1 plus Z2. Z1 series with Z2 series with I4. So kat sini relation IA1. Okay. Right. The fault current dalam ni dia bagi fault current because IB equivalent to minus IC and equivalent to minus J square root 3 of IA1. So yang mana you nak ingat semua perlu tak? Inilah kata please memorize this equation kena circuit. Derivation tak perlulah untuk buat derivation or this derivation. Tapi nak faham you boleh go through the derivation, that's why you dapat lah the final equation for the positive sequence current. Okay. Then we have line to line fault. Line to line tadi this one double line to ground. The third one double line shorted together and it connected shorted also with the ground. So this is the double line to ground. Relationship VB is 0, IVC is 0, and IA is 0. Different dengan line to line. Kalau tengok line to line, okay, because dia tak short dengan ground, so VB equivalent to VC. But in this case, for double line to ground, the voltages for VB and C are 0, and I is also 0. Okay, so this is the relationship of the zero sequence, positive sequence, and negative sequence with the unsymmetrical, the general equation, because VB, VC is 0, 0, 0, so dapat VA. So this is the I3, 1 over 3 VA. Sama lah tadi. Ini ialah kosong, kosong, that's why kat sini kosong, kosong, 0, 0. So you have this I3 over VA. I3 times the VA. Okay. So for the negative sequence, sama juga. The value of VB and VC are 0. So you have 1 over 3 VA. So from here we can see that VA1, VA2, VA0, all these symmetrical components, positive, negative, and the components equivalent to 1 over 3 VA from this substitution process. Kita substitute the value of each. Okay. So you do derivation semua ni. Later on, what you have here, you will have the general equation for this again this IA1 positive sequence current macam ni okay, EA1 Z1 plus ZO over Z2 divide ZO plus Z2 okay, so ini boleh nampak kat sini kan, this is E1, this is ini macam okay, ini macam parallel lah, parallel connection ni boleh nampak this is the parallel connection of between ZO Z2 okay, so this is the parallel connection between Z and Z2 okay, series kat sini, ini series lah ya. Senang je ingat so this is series, this is parallel. Yang case lain pun sama kalau case mana case this one ni series so you can see the circuit are in series, right, series plus series lah kat sini. Tapi however for this circuit, right, this EA1 is series with this Z1 but it's parallel with this ZO and Z2. So the circuit dia macam ni. Sometimes people say you boleh combine between the positive negative sequences, then it become the double line to ground circuit. Mana-mana you ingat cara itu pulang pada you. Yang paling simple you ingat sini ada series and the parallel. Okay. So you can determine the value of I positive sequence with the equation and the I fault current. Equation ingatlah ini untuk calculation for fault current, double line to ground fault. Okay. Unsymmetrical fault analysis. This one, I think dah explain kan dalam awal tadi. Okay, this one for unsymmetrical fault analysis. Okay, ini dah masuk pada calculation So tak perlu I cerita. Kalau I cerita sekarang pun you tak buat calculation pun you tak mungkin dia ada next class. Next week you break kan, you cuti kan? Betul? You ada break right?
Yeah.
Seminggu kan? Cuti apa minggu? Nasib. Bukan cuti exam break kan? Cuti apa?
Cuti
Wesak lah.
perayaan.
Wesak.
Oh, Wesak. Yelah, Wesak kan. Okay. Tak apalah. Okay. Kita stop at this slide And kat sini chapter 2. Ada lagi chapter 2 kalau dia punya sambungan continue to chapter 2 for analysis. Okay. Sampai sini ada any questions nak tanya? Rasa dah okey dah. Kita faham. Okay, kita boleh pergi pada next letter. Ataupun you ada something yang nak tanya, you can ask me now. Tak ada masalah. Orang tak masalah, sorry. Saya tak perasan. Mungkin dia masuk dalam. Okay. Ada apa nak tanya? Ya, 4.30. Semua okey? Semua sihat
Okey, sihat saya.
Alhamdulillah sir.
Baik Alhamdulillah Ada yang dah ambil vaksin kat sini? Ada? Ya?
Tak dapat sir. Klik
Tak dapat
klik negeri tak keluar.
Belum
sedih
sir.
sir.
Kat sini seorang pun tak ada?
Tiada.
Oh, how about your family ada? Kawan-kawan you, keluarga you dapat?
Family saya semua dapat.
Dah ada dah.
Macam
Kalau
mana
family
you
dah ada.
dapat You tak dapat?
Tak tahu
Tahulah.
Tak ada rezeki lah tu. Tak apalah. Mungkin Julai after June lagi banyak vaksin masuk. Nanti kita ramai dapat lah. Okay guys, itu saja. Thank you very much. Alright. Okay.
Okay sir.
Terima kasih sir.
Okay sir, thank you sir.
Thank you sir.
Sir.
Stay safe sir.
Yeah.